I want to have a quick look at these two UNI-T meters, which are the same, but in this one here, I did a little hack. I found a hack on YouTube, very useful, to modify the meter. So when I switch this on, this comes right on in DC mode. And this meter here, that's stock from factory, comes in AC mode. So first I have to press the select button to get into DC range. So now if I go up with the voltage, the second thing is, this here is now a 10,000 count meter, not only 2,000 count. So until like 2 volts, the resolution is about the same. But from there on, the meter down here, it's a software lock. It ranges up into the next range. While I still get the full resolution at the hacked meter, where we modified the data on the EEPROM chip on the meter. And in this video, I want to show how it is being done. And I show it in a very beginner-friendly way. Because there are YouTube videos where it's sometimes a bit hard to follow everything. Especially if you're a beginner and you have never done that before. But it's actually not too hard to do it. So here, now on the meter at the bottom we lose further resolution, which is really not good. Because I usually use it for batteries, like 50 volt battery systems, and well, now my power supply is maxed out. But you can tell that this is not enough resolution if you want to see small changes. So this hack of course works for the other ranges as well. So we go here up to 20 amps, and in the 20 amp range we go up to, well, 100 amps. It still shows overload above 100 amps. I didn't figure out how to change that. If somebody knows, please leave it in the comments below. So you open the battery compartment and you take out the batteries. And then you open these two screws to get into the meter. And that here, with this little dot here, that is the EEPROM chip that we can clamp on. We can move this a little bit out of the way here. And now this little reader comes in such a box. And it looks like this. So this device is what you have to buy, and it has to come with such a clip. And now we can put this here, there's a little one here, and the red one, that is the one that should go in the one. You know, when you buy it, it comes like this, and then you just plug it in here. And then you put it in here. I marked where the one is. Or you open first. You put this in here. And then you can close this. And it's secure in here. And this here, where the red cable is, there you clamp it onto the dot. So basically like this. And then you have a little USB cable. which you plug into the side of this thing. And now, with this whole assembly here, I go to the computer. It comes with this little CD here, and you insert that to your computer. If you have an optical drive, if not, you can always get an external optical drive. Now it comes up here, and you can copy this folder to your desktop. So now it's here, and now you can already eject the drive again. Now I plug in the EEPROM reader, and we have to go to the device manager because we have to install the driver. I'm not the main user on this computer, but here you go to update the driver. It's grayed out, so you have to know the administrator password. I will quickly click on this here and type it in. And then you can go to get your new driver. That is this one here. And now you need the path. And the easiest way to get the path is you just open this folder, you go to driver, and then you copy this path. And you insert this path here. And you go ahead, and the driver is being installed, and now, yeah, it worked. And you're done with that. The device works trouble-free. And it shows up here. So what we do next is we open the folder and click on the application here. And now we have to first change the language. Here we can change to English. So when the multimeter is connected, what you have to do now is to switch it on into the 2 amp range. Make sure that all these settings are set in this way. And then make sure you clip it on the chip, and then you go on read. And now you have this information. And now the multimeter is making like a beeping sound because it's kind of switched on and getting power from the EEPROM reader. So let's just read it again. You see now the settings changed. That's not good. Okay, now it's consistent. No changes anymore. I read it a couple of times. And now I can unplug the device again. Yeah. I'm gonna let the multimeter go through the cycles the whole time. And now you can save the settings to the file. You can give it a random name. And save it. In the next step, we go to the website. The German YouTube channel Bitbastelei made a very good video and put a lot of information in the comments below, including the link to the GitHub repository here, and also the calculator that he wrote that makes our life way easier. So the repository is here. Thank you very much for Ben for putting all this up. A lot of useful information and how he did it with his multimeter. You can also desolder the chip if it doesn't work in circuit. But for me it worked in circuit actually. And now let's open this calculator here. I'll put the link in the description as well. So here, right now, it's all empty. And at the bottom, you can see it's all red here because there's no information uploaded yet. And you upload the file now, this one, that you saved previously. And now the file fills out all this information that are preset in your multimeter the way it is shipped. Also including the calibration information from your specific device. And now it's all green down here. And now we can apply some changes. For example, the backlight, when it turns off automatically, I will set that to 3 minutes. And half an hour for the auto off function is good for me. You can also disable it by just setting a 0. And then you can either play around with these settings directly here, or you can use the presets, the quick settings, and swap DC and AC around. And now the DC and AC is swapped around for the voltage, for the 2 amp, the 20 amp, and the 100 amp range. And it starts automatically in DC mode when you switch on the multimeter. You can also swap continuity and resistance here, which is useful. I use continuity more often. And then you can set the 10,000 count basically. What it does is it changes the settings here for you. So now you have a 10,000 count multimeter. And well, there is a little workaround in this 2 amp section that you could use. Let's press it here. It adds a 6,000 amp range. Sure, it will display amps, but you will know that it's milliamps. Because when you press the 0 button on the meter, what it does is it's not a 6,000 or 10,000 count multimeter anymore. It's just a 2,000 count multimeter. For whatever reason, there's a bug on the chip. So I actually want these two modes prioritized. So I don't want to start in this normal mode because especially with those low currents, you always want to zero your meter. So I will go ahead and put in the 6,000 amp range here. And here I will select the 6 amp range. And I will put in AC 6000 here as my second function. And I'll just leave the AC 6 amps down here. Yeah, and now with all these changes applied, you can have a look down here. Yellow are all the numbers that have been changed. Now you can just download it. And here's your configuration. And this configuration you can now load in here. But what I do first is I plug back in the multimeter. Now it's plugged in. The multimeter is still switched to, in my case, the 2 amp range. So it's switched on. And now I read the information again. Yeah, it read the information, no change. So it's detecting, working well. Now it's beeping again. But what we can do now is open this file that we just downloaded. It's not in the documents, it's in the download folder actually. Yeah, that is the file. It says edited, and you open it. And now this file you can write to the chip. And write complete. You can read it again. Yeah, didn't change. It's on there now. So succeed. You can plug it off again. It's already plugged off, and now we can take away the clip from the chip and we can close it back. When you close it back into these plastic threads, make sure you don't like force it in and make a new thread, but you go there with a little bit of feeling. You turn it the other way until you feel it go in, and then you close it and you feel like that there's not much resistance to close. And then let's add the batteries. Oh yeah, it was still switched on. Ooh, you can already see that it worked. Switch it off and back on. Voltage, DC range, amazing. The second function is AC. Then we are back to DC. Here we start in a continuity mode. Ohm, diode, capacitance. And yeah, it always starts in DC. That's great. Well, we still have this offset here. That is quite significant. It is one of the downsides of this meter, but what we can do here, such a cheap demagnetizer you can get, and if you plug that in and you press the button, oh, you can already see how it goes down. And now you can basically go up, slowly go away from it, and then you can release. And there you have it. That's as good as it gets. And if you measure higher currents, especially if you switch them on and off while the clamp is on there, yeah, this offset is there. But that's why we have this 0 button. And you can see it shows amps, but it's actually milliamps. And if you go, there's the AC, that's a 6000 amp range again. And then the third one is the standard. And here's the standard range too. That actually shows amps, but I rather have this one here for me, because when I zero it, just stays like this. Yeah. So let's close it up entirely. And I hope your project is successful as well. It worked well for me. Make sure the contacts are there when you clip this on and it doesn't read firmly, that these little contacts actually have contact with the chip. That's not always that easy to achieve. Now you can see I turned the balancing on this battery pack. And yeah, this meter is actually pretty good. Fast update speed, good resolution. I could clamp it around while it was off and zero it. So yeah, that's pretty neat. One application would be to measure batteries. Here at the bottom, there's actually the UT210D version. It goes up to 200 amps, but I was not able to modify that one yet, not with the presets at least. And the one up here is enough. But you can see the difference now in this application. I want to measure a battery cell voltage here and see how it is performing over time. And you can see how useful the extra resolution is now at the top meter. You can see that there is a slight change in voltage. And at the bottom meter, which is not modified, you don't see this change. Yeah, so that is very useful in this application here. Also, if I want to measure like the whole pack voltage, let's just try it. Like this, you can see that, yeah, down here I just don't have much resolution, and up here I can also see quick changes in voltage. So yeah, hands-on review on this meter and how it's performing. Pretty nice with those battery packs.